Okay guys, final lesson. This is it. 12.4, honors. Okay, so we're going to find the volume of a sphere. And you're going to have to watch me careful here because this is some of the problem I'm going to do on the board is going to be crazy. Okay, so you're going to watch really careful. All right. So first, we're going to say, how is the volume of a sphere related to the volume of a cone? I'm actually going to answer that here. It says the formula for the volume of a cone is volume equals 1/3 base times height. Okay, so all we do actually is we multiply that by 2 to get the volume of a sphere. Okay, a little bit more complicated though than you think, especially because we need to also go through, and if you notice, we took the base here and we went through and substituted in, because it's a circle, pi times radius squared. You guys see that? So we do that, and then we can go through, and also the height here, the height, and I'm showing this right here, turns into 2r, because the height is the same as 2 multiplied by the radius. This makes it a little bit easier when we go through and distribute through here. Notice I've got 1, 2, 3, 4 different things I'm going to multiply that 2 by. Okay, and so then we end up with 4/3 pi radius cubed. Okay, so this is actually the volume of a sphere. If we find the surface area of a sphere, then we would use 4 pi radius squared. We take the third out of it, the additional radius. That's just a review of us doing that from the last lesson. Okay, guys. Now, our other thing that we want to realize is a hemisphere is just half of a sphere. Just in case you weren't familiar with that, it's half of a sphere. Okay, so we're going to try this. Hopefully I can get it on the first take. Should be interesting. All right, so let's go over here. Okay, so we're talking about XL. Ooh, I'm a little bit. Let's see if I can. There we go. Okay, so we are talking about XL number 1. Okay, we're going to do XL number 1. What they're talking about is you have a balloon with a 16-inch diameter, and they want to know what the volume is. But they also want you to then go through and shrink it down and tell you what the volume is if it were halfway deflated, and then also tell you what the radius of that volume would be. So you can tell how this gets really complicated really quick. So I want you to watch me real close. Okay, so we have to realize a couple things. First of all, volume is 4/3 pi radius cubed, which we established over there. Remember, when they say that it's a 16-inch diameter, that means that the radius is actually 8. So when I rewrite this, the volume equals 4/3. Now what I'm going to do is I'm going to automatically put this into fraction form. Everything into fraction. So the radius is 8, we're going to cube that, and we're going to put it over 1. Okay, guys? Now, when we do this again, then we're going to actually cube it. So 5, oops, I put 5, 4/3 multiplied by pi over 1, and 8 cubed is 512 over 1. Let me make sure that's correct. Yes, it is 512 over 1. Okay? Now, what we're going to do is we're going to combine the numbers. In other words, it's going to be volume equals 4 multiplied by 512 over 3 pi. Okay, that pi over 1. In other words, the volume here equals, so if I do this, I would multiply 4 times 512 divided by 3. Okay? And so if we do that, what we get is 682 and 6/10 repeating pi. Now here's your problem here, okay? You have to remember, oh, and this whole thing is in inches, okay? So this is going to be inches cubed. Now what you have to remember is they're going to want this in fraction form. So when I do this, any repeating decimal, if we're putting it into fraction, should be over 9. So 682 and 6/9 pi inches cubed If you simply punch that in though, into it, it's going to tell you that it's not correct because it's not in the simplest form. We have to reduce that, so that would end up actually being 2/3. So that right there is my first answer. That's the volume of that balloon with a 6-inch diameter. However, now we need to go through, and this part isn't too bad. You'll see, we have to go through and actually divide it by 2 so we know what the volume is if it were halfway deflated. So in other words, I would go 682 2/3 divided by 2. So then we would find out that it is, oh my gosh, I can do this in my head, 341 2/3. Okay, so this is, again, inches cubed. Now I need to find that. It doesn't actually ask for that, okay? We have to find that because they want to know what is the radius of the half deflated balloon, okay? So we found that. We found the volume of it, but now we have to actually go through and this gets really nuts, okay? We have to put that equal to the volume. Okay, so here's how this works. We go 341 2/3, and oops, almost forgot the one. And this equals 4/3 pi radius cubed. I'm going to rewrite this because I forgot the pi. Okay. 341 2/3 pi. So what I have to do is I have to isolate r because we want to find out what the radius is. So the first thing I'm going to do is I'm just going to divide by pi. That's gone. So that made that easy. That was easy, okay? But then what I need to do is I need to go through and turn this into an improper fraction. So if I turn this into an improper fraction, it's 1024 over 3. Now the reason I'm doing that is because I'm going to get rid of this 4/3. In other words, the 4/3 I'm going to multiply by its reciprocal, 3/4. But if I do that here, right, and that radius cubed is still there, I also have to do it over here, 4/3. So this is gone, right? And all I have is the radius cubed. Okay? Now, when I do this, which is kind of interesting, it ends up that, oops, I wrote 4/3, but it's 3/4. Sorry, almost made a mistake here. 3/4. So the 3's cancel out, and actually this 4 does too. This reduces down to 256. So let me rewrite this. So radius cubed right now is equal to 256. Now when you do this, guys, you have to be able to take the cubed root of this. That means I need to take the cubed root of this, because the cubed root is the opposite of cubed. Okay, guys? So this cancels this out, and I actually get the radius by itself. But when I divide the when I do the cubed root of 256, I get, and I'm going to write this up here so you can see how I did this, it's 6 and it just goes on. It's infinite. 3, 4, 9, 6, 0. So I have to just write it like this. But then I read the directions at the bottom of the problem, and it says round it to the nearest whole number. So what I would say is, for my answer in this problem, it's approximately, the radius is approximately, 3 is lower, so it is approximately 6. Okay? So not an easy problem. All right, so here's the deal. This is the last lesson. We got plenty of time to go over this stuff. So make sure you ask me questions if you don't understand it. And I'll even redo this problem in class and explain it again if need be. All right, guys? All right, good luck.